8-10, write each angle measure in radians. Alright, so we've talked about this. We've done it in class a couple times, and when you look at we know that a radian is equal to arc length divided by the radius. Alright, so when we look at this particular problem, they're not giving us what the radius is, but we know that if we have 90 degrees over 360, arc length is going to be times 2 pi r, and we divide that by r. And so what do you guys notice right away? What's going to happen with the radius? Regardless of what it is, this is going to cancel out, and then 2 is going to go into 360, so that's going to be 90 pi over 180. And then we can further reduce this to pi over 2. So 90 degrees is equal to pi over 2 radians. Alright. Same thing with B. We know that a radian equals arc length over the radius, and we know that 360 over 360 times 2 pi r divided by the radius is going to cancel. 360 divided by 360 is 1, so the radian measurements for 360 is 2 pi. Alright, and so then when we look at 180, we get C is, we can do the formula, but if we just kind of think about what we've seen, let's try that again. So if we have this circle, and then we have the XY coordinate, and I know that 90 degrees is here, so this is pi r2, this is 0. I know that if I go all the way around, that is 2 pi. And so if going all the way around is 2 pi, then what has to be 180 degrees? This would be pi. Okay? And when we do D, just to stick with the formula, we know that radian is equal to arc length over the radius, and we know that the arc length is going to be 45 over 360, and that's going to be 2 pi r divided by r. The radius cancels out, and then 45 360 divided by 45 is 8, so this ends up being, let me scroll this up a little bit, it ends up being 2 pi over 8, and so that reduces to pi over 4. And if we look over on our graph over here, where's 45 degrees? 45 degrees is going to be right here, so it's half of pi over 2, which is what? This is pi over 4, so 45 degrees would be right in here.